You're too kind. I submitted this presentation for DrupalCon this year. I don't know if it's going to be selected, but I submitted it with the tag of advanced level. So I'm going to assume that you're familiar with several concepts, and if there are things that you cannot follow, maybe that means that if you get more into this decoupled world, you'll be able to follow later. So don't worry if there are things that are a little bit too complicated, or maybe they are easy for you, and I'm just thinking that they are complicated. So with that, I already told you who I am. What I didn't tell you is that I also live in an island. It's much smaller than Japan. It's in the Mediterranean Sea, and there are many things that you have here that we don't have there. But we have beaches and palm trees, which is something, I guess. I still work for the same company, so I will spare you that. And in this session, we'll cover three main topics. The first one is how we base our job on abstractions, and how we can build on that concept to provide something that we build, or we increase the complexity of the projects that we do. Then I'm going to move on to something more specific, and I'm going to talk about a proxy, what a proxy can do for your decoupled projects, and what are the benefits of that. And finally, I'm going to try to merge those two things together and abstract how we build a proxy for our decoupled Drupal projects, and in general for our projects. But we'll see that. So enough of spoilers, and let's get into the thing. My first statement is that we base our job on abstractions. And so to explain this, I think that the best way is to think about how we did a Hello World project in the early 2000s, right? How you do a Hello World HTML application is you open up a code editor, you type Hello World, you save it as index.html, and then you're done, right? That's how you write a web page Hello World. In 2019, in order to write a Hello World, you need to download Node.js, download npm, do npm install global create React app, then use create React app to make a React application, open one of the JSX components, type Hello World, save it, start a web server, and then you'll see the Hello World, right? While it's fun to make fun of the React people and how they do this stuff, it is also not fair, right? Because in 2019, we built incredibly complex projects, and we didn't do that in the early 2000s. So think about complex projects like Netflix, right? If you open Netflix, it will not look like the same thing if I open it, right? It adapts and personalizes content. It may be something that is configurable that you have, that I don't. Some people may have page features that I don't have. I don't even know if that's possible with Netflix, but that would be something that could be done. And they do experiments all the time. I don't know if you knew that, but for some users, they serve some features and they see, okay, that didn't change their behavior in the way that we wanted to, so we're not going to go with that, and they try this stuff. So those are very complex features that more and more often we as developers are asked to implement in 2019. And how we got here was because we have some solid abstractions that we can forget about the basics. In other words, let's think about a concrete example. So imagine that you're writing your JavaScript app and you use the fetch API that comes with the browser. So you type fetch, you provide a string, which is the URL, and you get back a promise that eventually it will succeed or fail. And you don't think when you write into that for that to happen, you need to write a text document, which is an HTTP document that has key values for the headers, and then a double space and a body, and then you need to open a TCP connection and start sending packages, but not after you've done the three-way handshake to authorize a connection, and then in order to send packages, you need to send electrical impulses to your network card, right? You don't think about any of that, because that would be crazy. Like having to write impulses to a network card every time that you want to do a fetch, like that's not feasible. So we just, in the technical community, worked on that problem a long time ago. It was a very fun project to be able to solve that particular problem because there are many network cards. How do you deal with that, right? Many vendors. How do you know which card you're dealing with and stuff like that? But that problem is solved. And nowadays, we can build complex stuff based on these abstractions. So there are many levels of abstraction, and we are progressing higher and higher on the levels of abstraction that we can rely on. So we are no longer based on functions as levels of abstraction, but we also abstract whole features. Like if you start a project, you could start it from scratch. You could build your own homegrown application. And probably one of the first things that you would do is to write your user management module, right? And for that, you would have to write your hashing algorithm for storing passwords, etc. But you don't do that because you have things like Drupal, right? Drupal abstracts whole feature sets. It gives you a new level of abstraction here. It is not just a simple function, but it gives you things like group management or user management, or it gives you like content modeling tools. And actually, that is the feature that I like the most about Drupal. The content modeling tools that Drupal has is superior, in my opinion, to anything else that's on the market for CMS. There are other ways that other projects are solving the problem. We have the entity API. Other projects have active record patterns, which means that they write classes in PHP or Ruby or whatever language, and those classes map to database layouts. That's how they do it. There are other projects that use ORMs, like Doctrine, etc. Right? In Drupal, we have our abstraction, the entity API, which means that whenever we want to read and write to the database things that are content or even configuration nowadays, we use that. And every single module in Drupal, we know we have entity API that we can rely on it, and we can start building other more interesting things without having to worry about database connections or writing SQL. I've been doing Drupal for a long time, and I haven't been writing any SQL queries at all this time, right? So that's one of the things that we can rely on. So we keep building on abstractions, and what I want to achieve is to abstract this whole PHP so we can just do some Node.js, right? And that's on the backend part. On the front-end part, you can do what you want. Some will advise you to use Elm. Some will advise you to do to use something else. But in the backend, that's what I would like, to have PHP abstracted out, right? Because that makes my life easier. And in a sense, that's already done, right? Because if we are saying that Drupal is handling your content repository, right? Because it has the abstraction for the content modeling tools, and it's one of the best of the market in doing content modeling, then it is already abstracted out, and that was one of the aims after the Contenta project, to be able to just rely on that as an abstraction, to have decoupled Drupal. You could replace here the word Contenta CMS with decoupled Drupal, because Contenta CMS is only a set of modules and some configuration, and that's it. But the whole idea of decoupling Drupal is because you take a content modeling tool and now it's abstracted, right? And you can just use it without having to worry about what's underneath, just like the fetch function that I explained before. So some of the nice things that happened in order to provide these abstractions are you have a completely available content repository for read and write using the JSON API project, and that allows you to get data from the server and put data on the server. And in that sense, we are almost done, but there are other things that are necessary in order to abstract the whole Drupal. Like, for instance, authentication, right? When you are in a decoupled project, you need to have authenticated users, because many times when we go on a stage and we talk about decoupling and decoupled projects, we merely think about read-only projects for anonymous users. And that may be fair in the sense that it is the most common use case. But it's naive to think that all projects are only for anonymous users and are read-only. So for that, we need to provide a solution for authentication. And that solution is OAuth 2. It's the leading standard on authentication, on delegated authentication, meaning that your users will go to your React app, but they are authentication thing or authorizing operations against the Drupal server. The Drupal server is the server that knows if you can do that operation or not, right? And OAuth is a solution that lives out there, and there is a module called Simple Auth that will allow that. It also comes with another standard, JSON RPC, in order to execute tasks remotely. And that is just things like clear caches remotely, or send the mailing list remotely. And it's not related to content itself, but to manual tasks that you can program and trigger from your decoupled applications. It also comes with performance improvements like JSON API boost, like sub requests, and consumer image styles, which we talked about earlier in the question section of the presentation. It comes with these application enablers. I talked quite prominently about JSON API hypermedia, and I'm going to spare you this time, but this is a way that you can in general, solve the problem of conveying business logics. Like I talked about the add to cart product example, but it could also be something as simple as I'm getting a list of entities, and these entities I need to maybe render a delete button or not. And if I have a link for the delete button, it means that this user has the actual permissions to delete the entity. And if it doesn't have a link, it means that it hasn't. The same for JSON API schema. JSON API schema made it to this presentation. It didn't make it to the other. It just gives you the introspection tools that you need for the generated API. And finally, automatic documentation using OpenAPI. OpenAPI, again, a different standard, another standard that is specific for that task, and it gives you nice documentation of what your data model is. So if you want to know what the data model that is in SQL that somebody clicked together using the tools in the Drupal admin interface, then you go and open this OpenAPI, and you can see the documentation there. You can see all the fields and everything linked together. You can click, and you can even see descriptions, etc. So the question is, well, we have Drupal, the content repository, abstracted out. It's a black box. It lives somewhere, has clear rules of interaction, but can we do something else for these rich and complex applications that we are asked to build as developers? Can we move further up the stack to do that? And my answer is yes. And my answer is that I want to have every decoupled Drupal project to become a Node.js project. And that is something that I can say here safely, because you're all nice people, and because this is an API first presentation. But in a Drupal conference, someone just, when heard this, someone just got up and left the room, right? But let me explain, before you leave the room, let me explain. If you're building a decoupled application, and that probably means that you don't have just one single site, but you are building a decoupled application because you have a JavaScript site and an Android app and a Samsung TV app and maybe an Alexa skill, right? You have to build all this, and then you say, okay, now it makes sense to build it decoupled. Not just because it's cool to build it with whatever, Vue or Svelte.js, right? But chances are that whatever you build, in that set of applications, there will be a website, right? That is kind of the common thing about all these projects. And that website is likely to be a JavaScript framework. If you have a JavaScript framework, then you will want to have server-side rendering. Now, server-side rendering is a technique that allows these JavaScript applications to be more performant and have better search engine optimization, which means that people can find your web page and it loads way faster, right? I don't know of any enterprise scale application that doesn't have server-side rendering that is built with a JavaScript framework. So, in order to build server-side rendering, you need a Node.js server, which kind of leads to my previous statement that I want to transform every decoupled Drupal project into a Node.js project. Because you will have a Node.js server for server-side rendering. Now I'm going to make my case that you also want to have a proxy.
Sorry, but what do you render there if you have different consumers? Sorry.
We'll get there. We'll get there. So I'm going to make the case that you want a proxy to render your, you want to have a proxy in between your applications and your site, right? And your Node.js server, which will render the JavaScript site, will also host that proxy, because you will need something, some backend server to host that proxy. You have one available, so let's put the proxy inside of Node.js. So let me see if I can convince you that you want to have a proxy, right? So the benefits of a proxy. The first is flexibility. As we said, you have 3 different technologies here. That's what you are asked to build, and this is something that someone else builds, right? Let's forget about how that gets done, because that's front-end stuff, and that's way more complicated than the stuff that I can do. So I'm gonna just do the back-end stuff. So for me, I'm gonna have some content APIs, right? And I say APIs, and they are represented with the Contenta logo there, and those are the decoupled Drupal projects. And it may be more than one. And actually, I hope that you end up with more than one Drupal installations in your project. And again, we'll get to that later. But nowadays, chances are that you will also have to interweave or to put in your project data from other APIs that you do not own, third-party APIs, like weather information, or baseball scores, or could be anything, right? So you need to put that in your application. So how you put it in your application could be centrally controlled by a proxy, or you could have each one of the consumers implementing and calling these different APIs. That means that each different developer working on these consumers will need to learn how the weather.com API works, how the baseball league API works, and implement like the intricacies of each one of these. Like maybe the weather.com wants you to pass a special token because you need to be registered into a whitelist, otherwise they think you're spamming them, right? So why not centralize that and do it once and serve everyone later, right? So the proxy would do that. But it doesn't stop with requesting more data to other services, because these your content APIs plus the other people's content APIs are very similar. It only changes the ownership of the data. What is more interesting is that you can have services like, for instance, A/B testing, right? There are A/B testing services that will let you create experiments and let you define how you want to test that experiment, and you create variant A and variant B. Variant A of this landing page will feature these 3 blog posts and these 3 quotes from clients, and variant B will feature these other 3 blog posts and these other 3 quotes from clients, right? And then to half of the visitors of your site, you're serving version A, and the other half you're serving version B, and then you're reporting which one is winning. You measure which one works better, maybe which one leads to more sales, or maybe which one leads to more clicks on the contact page, or whatever your measure is, right? So again, the proxy is the way that you can centralize that and deal with okay, version A, this user comes for version A. So I need to request this data from the whole array of data services and then go back to the user with that. And like this one, like this variant, there are many variants that require some computation of the responses that you get and modify everything to serve to the application. Personalization is another example. There are startups that specialize in clustering users and segmenting the user pool, so you can have people or users that are alike to give them the same experience. But this other set of users get a different experience. Going back to the Netflix example, people that like to watch cartoons or people that like to watch kids' movies are going to get different results than people that like terror films, right? So they are segmented differently. And all this can be done in the server by the personalization service. The proxy, the request comes in, the proxy calls the personalization service and goes back, and then the proxy says, okay, these are the terror film people, so it's going to get the data that is appropriate for them and go back. Instead of having each one of these go and understand the personalization service and do all the dance back and forth. And we'll see that doing it from server to server is more performant, right? Other examples, trunk-based development. There is this way of development where everything gets pushed to master and then automatically deployed in production. However, everything that is new is deployed under an if statement. And then what you do is everything is disabled by default. And then slowly to 1% of users, you start enabling that feature. And if everything goes well, you go from 1%, 10%, and then you roll out to everyone, right? And you can this way evaluate and even do QA in production. The trunk-based development people say that if you haven't tested in production, you haven't tested, right? Well, you could do that and only enable for the QA people that feature. Again, if you control that at the proxy level, in the centralized place, you don't have to do this again and again in the different environments. So you may think, well, I only need this. I don't need any of this, right, in my projects. Well, you don't need it today. But adding a proxy is not an extra work. It's just another different place to put that work. And if you do it, you'll get the benefit of being more future-proof. So whenever you have to place that weather information, you'll be ready for it. Another benefit is performance. As you may guess, the performance is better with this architecture. And that is because not only server-side rendering, as I mentioned before, because your JavaScript application is rendered on the server and then is cached and can be served from a CDN, etc. But also because Node.js has non-blocking I/O, which means that here we are making a lot of requests, as you can see, right? Having those requests made from Drupal. So if the user goes directly to Drupal, and then Drupal has to go to each one of these services to collect all the information and make all the decisions, in PHP, that means that you can only have one request going on, and then you have to wait for everything else. In Node, you have many in parallel, and it's much faster. Also, the fact that you are making requests from the proxy to these other services means that you're doing server-side to server requests, which are much faster than server to client because you have good, reliable connection, right? You have a data center with a very thick fiber optics cable, and that makes a connection to another server that's under the same conditions. When you write a Node.js proxy, you write it stateless, which means that you can scale your servers much easier. So there are many factors that make this approach much more performant. It's also more secure. I think that Preston mentioned this before. So the idea is that you establish a private connection between Drupal and your proxy. These are two servers that are talking. So you put those under the same VPN, and then you give your editors that go and edit content into Drupal access to that VPN as well. And that means that no one else in the world can access your Drupal. The only surface that you offer to Drupal is whatever the proxy needs. Which probably means that you won't have, or users won't have, any access to admin routes or node routes or the val.php routes, which some people still have in production, or user login, right? And even if a module that you're using has vulnerability or a security problem, chances are that since you're only exposing to the end user the things that you just need for your page, chances are that you're not affected by it. So let's recap. It's more flexible, it's faster, and it's more secure. Hopefully everyone wants these things, right? Wanting the opposite would be very weird. More insecure code, slower applications, and less flexible applications would be very weird. It's also more robust, and I like to talk about this in the terms of robust flexibility in the following sense. So imagine that you have a decoupled Drupal project, and you are making requests from your consumer, from your Android application, directly to Drupal. And Drupal goes down for a reason, and everything is broken, right? That is a critical emergency. You need to get a backup from that, figure out what happened, make it not happen again, and fix it as soon as possible. If you have an architecture like this one, and now the diagram is going to change a little bit, so I'm going to first explain the diagram. And you have an architecture like this, where the editorial team is in charge of the blog, right? But then the personalization team, so the people that are in charge of your personalization content or business rules, are in Symfony, and the marketing maintains the landing page apps, which are kind of targeted to get the people what they need, so they can drive sales, etc. They like to have their things in Netlify, right? Because that's the best tool that they have available for their job, and they take it, and you put everything coordinated behind the proxy. Now, in this situation, Drupal goes down, right? And you need to figure out what happened. You need to figure out a way that it doesn't happen again, but it's less critical, let's say, because now only the blog is gone, and hopefully most of the people in your project are going to the landing pages and buying everything like crazy and making your business very successful, so they can hire you to build more things, right? And then you get a salary and get to pay for stuff. So in this case, the application is more robust because you hid each one of these things as silos, and since every everything in your application is distributed, you can afford yourself to have a little bit of downtime in some of them. In this past slide, I introduced something that wasn't really related to the topic of the presentation, but I think that is very interesting to explore when you're building a decoupled application. And that is that I talked about the very basics and fundamentals of domain-driven design, which puts the focus of the architecture of your application not on the technical solution that you want, but on the team that is actually working on the application. So imagine that you have a project, and that project has customers, and you offer support for them or customer success stories for them, and you also have a sales team, right? And that sales team is trying to sell stuff, because otherwise you don't get any customers. These two teams work under the same domain, which is whatever your business does or your client's business does. And they are likely talking about the same things, but their realms are different. One deals with tickets, what's the status of the fix for this problem, deals with customers, and deals with resolutions and stuff like that. The other one deals with selling products, stakeholders, what's the sales pipeline, and I don't know enough of sales to keep saying stuff. So there are some bounded context between them. They are likely to have some things that are common and that put those two domains in contact, like in this case it would be the thing that they sell, right? The product is the same that what they sell and that what they offer support on. And the principle of the domain design is don't try to force two teams to fight, right? Don't force the sales team to use your Drupal application. Let them use Salesforce or whatever they want, and then allow each different team that has a different job to do inside of your enterprise to do it with the tools that are best adapted to them, and then put everything underneath that proxy and have a comprehensive output for the end user. And now, the first time that I did this presentation, I was rehearsing it, and I was trying to come up with the whole discourse, and I had a typo in this slide. And I didn't realize I had a typo until the last day before presenting it. And it was a fun typo, so I left it so you can see. That was my initial slide. Anyway, moving on. So as I said, our job is based on abstractions, right? So how can we abstract building this project? Well, I started a project a while ago that tried to go on that direction. Lately, there is not much going on in here because the questions are still not answered. What do we need to abstract, right? What are the things that are common to all our problems? Because, as I said, it's not only that we do different things, but we do them differently. And if I'm advocating for each team to have the tool that best suits their needs in each different project, it is likely that we don't have much in common in how we do things. So I'm going to show a diagram. It's a complex diagram. Please don't look at anything except the things that I highlight, because otherwise you're going to just not focus on the point. So, do I have the diagram? Maybe I skipped it. Right. Okay. No, sorry. I hid the diagram because it was too complex. But the problem is here that we auto-generate the proxy based on OpenAPI. Remember how I said that I was going to talk about OpenAPI a little bit more? And based on that auto-generated proxy, because we do it with the Drupal API module, that proxy is a place where you can put the other sub-projects open API description. So the personalization team may want to write their own open API document and put that document inside of the proxy that was auto-generated for Drupal. Because this is a thing that is for Contenta, which is a Drupal thing. So it is auto-generated for Drupal, but not for everything. But if you bring in your
What do you mean by auto-generated? Like the routes are configured, or?
So by auto-generated, what I mean is that you enable the OpenAPI module, and it gives you the description of your API. And that description of the API is imported by the proxy and stored there, so it can give you the routes and everything, and it knows that, oh, I have, let's say, a page/API/page route, and that is for Drupal, because I imported this document from Drupal, so I'm gonna send this request back to Drupal. And if the Symfony project provides the OpenAPI description, and then it's imported in the Node.js server and into the Node.js proxy, then the proxy knows, oh, I need to send this to the Symfony application, to the personalization service. So what is an OpenAPI document? This is a quote from the OpenAPI initiative, which is part of the Linux Foundation now. And the most important part is when it says that it's a vendor-neutral open description format for APIs. So vendor-neutral means that any API can be described by OpenAPI. And it's a description format, tells you that it's a way to explain to a machine how the API works. And then it has some buzzwords like accelerating the vision of a truly connected world, which sounds nice. So, as we were mentioning a moment ago, when the proxy starts, that proxy that Contenta.js creates for you, it will download the OpenAPI document from Drupal, and it will read of the routes and the schema. And now it knows that, oh, I have this route available in Drupal, and this request wants this route, so I'm going to send this to Drupal, right? And it will do the same for the other parts if they provide this OpenAPI document. Now, the OpenAPI is very, very successful and is very popular. And chances are that a Symfony application will have a way to auto-generate the OpenAPI description, or at least some enablers to make it easy. And it also has not only the routes, but the schema of the responses. And that means that if you have the schema for a page, right, you also know if a consumer is trying to create a page, then it has to meet these properties. It has to have a title, etc. Otherwise, I'm not going to bother Drupal at all. And if we put a proxy in between with these conditions, you know all of the routes that are accessible across all the pools of your services. And then if that route is not available in any of the services, you respond really fast from the Node.js proxy saying, hey, this is a 404. You don't even bother Drupal. Because for Drupal to realize that you have a 404, that takes a stunning number of computations to do that, to put it in a nice way. So while I was doing this, after writing this many slides, I realized, oh, that's what API Gateway does. Every cloud provider has an API Gateway. AWS has one, which is called API Gateway. IBM Cloud has one called API Connect. Google Cloud has one. Microsoft Azure has one. So how it works is how it could work is you put your API gateway in here, which is nice because you don't have to write anything, you don't have to host anything. And
sorry, I was almost able to follow up until now. Well, what do you mean with gateway?
So an API gateway is what a cloud provider puts in between your backend services and your clients in order to make them accessible through HTTP. And it lets you have some rules to use it as a proxy as well. And all cloud providers have this because of something that I will tell in a minute, right? So I was experimenting with this, and while digging on this, I was like, oh, they even have support for OpenAPI, which was like, I feel less special and less smart now, but also, well, I feel a little bit validated, right? It's not a crazy idea, right? But the problem in this is that an API gateway is something that just passes along things, right? It doesn't allow you to do these computations that we were saying, like change the response that we get from the data services based on some other APIs, other services that are not for data, but for business logic, right? So it would be like getting data services through the proxy, which means through a single domain instead of having like many different domains. We do it through a single domain. That's true, but you only pass transparently the data, which kind of is still an improvement, but kind of defeat the point of many of the things that we said. The solution for that these cloud providers give you is, well, you need to add a Lambda function. A Lambda function is a cloud container which gets created on demand. So once it's pretty cool to know. When a request comes in, the server, it's like a very thin server, gets created when the request comes in. It serves the request, and then it disappears, right? It's not as beautiful as I described it. There is some nuance involved, but that's kind of the main idea. So they say, if you need computations, just add a Lambda in between it.
How about the difference about traffic amount between API Gateway and Node.js? How about the difference?
See, yeah.
Whoa.
That's my next slide.
Whoa.
So that's the thing. There is no difference. Lambda is actually a Node.js server. So that's a pretty valid solution. So if you like to have Lambda in your proxy, go for it. If you want to have a hosted Node.js server, go for it. I personally have been working with lambdas very successfully for some things and very frustrated for some others. Like lambdas have limitations. May have limitations with very high traffic that your project will never reach, or may have limitations with concurrency or sharing state. Like for instance, if you want to have application cache in Redis, accessing it from a Lambda requires some dirty tricks that are not really supported by the cloud providers that may break at any given time. So it has some limitations that may not impact your project at all.
Wait, why? Just an Node.js server and spaces?
Well, the problem is how they technically create these lambdas. So when cloud providers create these lambdas, you configure it, and what you configure it is you can think about it as the Docker file, right? And then they do Docker app for that server, and it stays up for a while. But if you need concurrent requests, since they automatically scale up, and that's one of the benefits, the problem is that they cannot scale up infinitely. They can only scale up like as many IPs that they can provision, and that's a limited number if you want to have lambdas that are deployed inside of a private VPC, which is what you need if you want to have Redis. And so it's like there are edge cases that you can reach. Hopefully you will not.
Yeah, but also your Node.js server could reach similar limitations.
Oh, your Node.js server could reach similar limitations, or let's put it in a
different problems, let's say. But yeah.
Yes, your Node.js server doesn't scale automatically like
right.
Lambda do.
Like Skype knows.
Maybe, I don't know. Yeah, but there could be techniques that could help with that. But yeah, the point is that either of these are great. So would I use this pattern everywhere? And I'm going to give you a hint. I read somewhere that every headline that ends with a question mark can be summarized by the word no. So, no, I wouldn't use this everywhere, right? There are edge cases, like maybe the 2% or the 5%. Let me think about one. Is an intranet, right? An intranet that only deals with authenticated traffic, which serves a very low amount of traffic. You don't care about performance. It is not under scale, and it's only for authenticated users. So you don't need to have server-side rendering. Therefore, you are not forced to have a Node.js server. Therefore, you could have this proxy in another language if you wanted to for that project. Does that make sense or not? I know, kind of depends on the project. I would say that I would use this pattern for decoupled projects with more than one consumer 98 times out of 10. There, you have a number. So, not everywhere, but if you fall in the right topology of your project, I would. And that's it.
Any question?
Yes.
Okay.
Yes, I have a question.
But I think I saw his hand first.
Sorry. I tried to follow, and I think I got it, most of it, but I am a front-end developer, so it made me think of service workers, actually. the service workers in JavaScript, and they do all the exact same things, yet they do it on a different level. So while in my notes I'm calling this a proxy server is some kind of a caching layer across servers, because if one of the underlying services goes down, it kind of cached what it could do, or in some cases, I guess. But what if you move the location of that layer or server to the end user's device? Then you would actually not even ping the server if the content is the same, for example. So with service workers, you could have a mobile application, in case that we're talking about a website, obviously, where the entire application is cached on the end user's device. So the performance benefits would be similar, I guess. But then also, you could still invalidate content by using service workers to like ping all of these services to go, okay, what changed and what couldn't change. I'm not sure if the link or if my assumptions are correct.
They are correct in most of the cases. I don't think those are incompatible. The solutions are incompatible, but maybe using everything in every project would be an overkill. The place where it would not work is whenever you have to change the response based on the response of the data based on the response on other services. Like for instance, you may have something cached because you visited this site and previously you were under an experiment and you don't know about that, right? The server put you under an experiment, an A/B experiment, and you got, I don't know, version B. And then we realized, oh, actually, it's not version B, it's version A, or version C, whatever, right? So the content being cached on the end content, the Drupal content being cached on your device may play in that scenario against you. But if it was cached in the Node.js application, it would be fine. Sorry, in the Node.js proxy, it would be fine, because then the proxy would have a version A cached, but it's not actually requesting version A, right? Because it knows about the A/B testing server.
So it's kind of depending on if you want that cached version to be before or after the internet connection, I guess, the device.
Yes, yeah. For that to work, like for browser cache to work in that sense, while still using these new complex features like A/B testing, personalization, etc., you would have to have the browser go first to the personalization service and see if you want to still serve that content that you have cached. If you are serving that, great, you serve it with 0 milliseconds. But if you don't, then you need to go back to the content server and request that content. And that kind of forces you, in order to use the browser cache in that scenario, forces you to implement that logic of knowing if you're in an A/B test or if you're doing personalization in each one of the consumers instead of doing it once. So that's why I say, yes, it would work, but if you have any of these services that changes the data that you get depending on, I don't know, some person flipping a coin, then it would.
Yeah.
From your experience in the project that you've done, how badly, if any, were those proxy servers being used? Meaning, it seems like that's the go-to way of fixing different API calls. So I can assume that they probably became, again, just a hunch, became way more bloated than initially anticipated.
That's fair.
And keep it real.
I'm trying to find an example and counterbalance. Yeah, it depends. Like, if you want to go for the quick and dirty solution, I guess that it's a very good place to put it. Quick and dirty have their reasons, right? It's technical debt. Technical debt is just regular debt. When you want to buy a house and you don't have the money for it, you go into debt, but you get a house, right? When you have technical debt, it's because you want to fix something quickly, but the problem is complex. So you do the quick and dirty thing, and then, but you get it fixed, right? So it's a trade-off. I would say that yes, it's a very tempting place to go and put your if this, then do that, and you change it there instead of going to the root cause, right? That's where I think where you're going. But also it offers you a place to do things like the weather API doesn't give you the appropriate cacheability metadata. It says that you cannot cache anything that they provide. That's a problem because CDNs respect that, and browsers respect that. And you know that the weather doesn't change every microsecond, right? It changes probably every hour at most. So you could use it to fix those things. Or imagine that you have something that I worked on is a service that provides an API for reviews on your projects, on your products or your digital products. It's called G2. And in order for you to access that API, you need to provide a token to say, hey, these are my products. But if you want to make those reviews public, how do you do it? You definitely don't want to provide that to every consumer, right? Because JavaScript just puts it in the plane. So it's a good place to put it. So yes, it can be abused, but it's definitely useful in many scenarios.
This is just my personal question about Node.js. What do you think about using Node.js for IoT business signage? Do you feel good?
I don't think I have enough experience to answer that question. I would say that I haven't found many limitations in working with Node.js, but since I don't have the expertise on that particular area and space, I don't feel confident to say yes or no. But I haven't found any limitations. So,
I mean, you're saying Node.js, but it could have been a Symfony application, whatever, as long as it's stateless. Like, you don't really care if it's Node.js.
I think a Symfony application wouldn't have worked because it's still PHP and has blocking I/O. So there are other like Go.
I'm just saying it doesn't necessarily have to be Node.js as long as it's stateless, as long as it doesn't have a database. That maybe.
Yes. However, you are going to have a Node.js service because you're doing server-side rendering for your JavaScript application. So, given that you have a Node.js server, you can have the Node.js server that only does server-side rendering, that's true, and then have your proxy written in Go or Rust or Haskell, right? But to me, that seems like a waste of resources. But you could argue that, yes, if you want to host both things. Well, thanks again for your patience.